Hi there! Here we are with another episode of the Theremin Project. Today we will talk about the Voltage Controlled Amplifier or VCA. We will not explore all the details of the VCA, but we will concentrate on the first stage of it, the one that converts the pulsing positive wave coming from the volume resonant circuit into a variable DC voltage that will control the next stage of the VCA. But before getting into the details, let me anticipate that at the end of this video I will have a giveaway for my followers. So if you are interested, follow me through the end of the video to learn about the details. And now, with no further ado, let's get into the details of the VCA first stage. The purpose of the VCA first stage is to convert the positive pulsing wave coming from the volume resonant circuit in a DC voltage that will be used to control the audio volume in the next stages of the VCA. It is made by a single NPN transistor, a BC547, polarized on the collector with a total resistance of 11 kΩ, divided in a 1K resistor and a 10K resistors in series. A filtering capacitance is attached in between these resistors to remove all the noise coming from the power supply. The capacitance is made of two capacitors, a 10 microfarad electrolytic capacitor, which takes care of filtering out the low frequencies, and a ceramic capacitor of 0.1 microfarad, which takes care of the highest frequencies where the electrolytic capacitor is not able to work. The base of the transistor is directly connected to the volume resonant circuit, which has a peak-to-peak voltage low enough to not destroy the transistor itself. The output is on the collector, where another capacitor of 10 nanofarad is used to actually level the signal and make it become a variable DC voltage. Basically, this stage is just a converter from pulse to DC voltage that also acts as an amplifier, changing the output level of the volume resonant circuit to a higher value more suitable to control the next stage of the VCA. First thing I did was to build the circuit on a breadboard to test its functionality before soldering all the components on the perf board that hosts all the other components of the Theremin. Then I connected the output of the volume resonant circuit to the input of the circuit on the breadboard and also connected the oscilloscope to the output of the first stage. With my surprise, the circuit was not working. I wasn't getting the right output on the VCA first stage. The voltage was basically a fixed voltage equal to the power supply of the stage. After a few tests with the oscilloscope, I realized that the input voltage of the pulse wave that is supposed to control the VCA was not high enough to control the transistor of the new circuit. Something was wrong. Instead of obtaining a voltage of about 800 mV as I expected, I was getting only 400 mV, which is below the thresholds needed to control the base of the transistor I am using in the VCA first stage. A little thinking later, along with an examination of the schematics of the volume resonant circuit, showed me that at the interface between that and the VCA there is a 10 picofarad capacitor, which is basically in series with the capacitor at the input of the volume resonant circuit. This capacitor lowers the voltage much more than I expected, so the signal was not high enough to control the VCA. Considering that I am working with very low capacitors, and considering that the transistor itself has its own capacitance between base and emitter, I decided to cut the chase and totally remove the 10 picofarad capacitors at the output of the volume resonant circuit. Once I did that, I obtained the voltage I expected, a pulsing signal whose peak is about 800 mV and that decreases when I put my hand close to the volume antenna. Satisfied with that, I then checked the output voltage of the VCA first stage and, sure enough, I got a low voltage value that increases when I put my hand close to the volume antenna. Also, the output signal is much higher than the input. It gets closer to the value of the power supply when I close my hand to the volume antenna. Perfect! That's exactly what I wanted. Clearly, now I have to modify one more time the schematic of the volume variable oscillator to remove the 10 picofarad capacitor at its output. Its schematic now looks like this. The schematic is also updated in the repository of the eleneasy.com webpage, so you can go there to get its latest version along with all the previous schematics of the Theremin and the new schematic of the VCA first stage. And for now, that's all. In the next video I will show you the next piece of the VCA and how it integrates with the rest of the Theremin circuit. And finally it is the giveaway time. I wanted to do something to boost subscription of my YouTube channel and to the paid Patreon account. So I decided to give away 3 resistor substitution boxes like those in the corresponding video I recently made. You can find the link of that video in the description below. The 3 devices will be drawn among all my current Patreon supporters. The draw will happen on June 30th and the devices will be sent to the winners immediately after. To participate in the draw, just go to my Patreon page and become a Patreon. All tiers will participate in the draw with equal chances to win. Thank you for supporting my channel, see you next time and as usual, happy experiments!